Okay, we'll give it just a minute more to get started. If anybody has any presentations, if you could bring them to Kara and just pass them over to Kara. For those who are presenting and I don't have your presentations yet, just go ahead and send them to me after the meeting. We'll try and get them posted online sometime tomorrow. So this is the February water supply meeting. This is part of the Idaho drought plan that once a month through the snow accumulation period up to the meltout, we would get together state and federal agencies as well as power company and others who are into water supply and discuss the situation so that we're up to speed each water years as we approach the period. So we'll have another meeting in March, another in April, and then probably one in May. After the last couple of springs, it just seems like a good idea to go into May since a lot can happen in the springtime. So with that, we'll go ahead and get started. Kara, can you pull up my presentation? So, yeah, if you just go over to the folder, it's right there.
Is this you?
Yeah, that's it.
Great.
So don't forget, it is Valentine's Day. If you forgot, this is a good opportunity to have a reminder through the little heart in the corner. But we're off to a nice snowy day today, and we're supposed to get some decent precip, or we should have got some decent precip up in the mountains last night. I didn't track it yet, so we'll have to get an update from the NRCS on that. But I'll go ahead and start with a brief drought update. So we've had 2 years of drought statewide. It's the third year of drought on the Big Wood and Big Lost. And you can see in 2021, we had the exceptional spring drought. We haven't seen a spring that dry since 1924. And by the end of the season, the map on the left shows that the drought was exceptional. That means the drought of record up in the Palouse and over on the Lemhi. And then it ranged from severe to extreme across much of the rest of the state. By the end of last water year, which is shown on the right, we had moderate drought across most of the state with some severe drought on the edges. We definitely improved, mainly because we had a very cool spring, and in the Boise region and Payette region, it was quite a bit wetter than average. And so the state's kind of on a slow recovery from that extreme drought in 2021. And if you look at the most recent update that came out from the USDM, we still have severe drought in the southern extreme, and that's a little bit due to reluctance south of us to improve drought conditions because of the multi-year drought down in the Great Basin. It probably overemphasizes our drought conditions. But I think moderate drought is a pretty good, which is that beige color or tan color. That's a pretty good representation of where we're at. We had a pretty dry October, and then the snowpack came in strong on top of that. And if you look at forecasts, they tend to be lower than snowpack. And I think that's kind of looking at the low base flows, just the dry condition over the last 2 years, kind of the memory in the system. So here I've listed all the basins from the Kootenai in the north, then down around the state to the Hawaii. And these are categorized according to drought colors. The only place where we have drought from a snowpack perspective, we have SWE across all across the chart, except on the far right. That column represents stream flow forecast from the Northwest River Forecast Center as a percentile. And so you can see that we have kind of a moderate drought condition on the Kootenai, which just cuts through the corner of northern Idaho. And then the Pend Oreille, Priest, and Spokane are all drier than normal, although the forecast on the Spokane is still kind of out of that drier than normal category, kind of more in a normal range. And then the green represents wetter than normal, and the light blue, a moderate kind of pluvial situation perhaps, although we're not accumulating a lot of snowpack in that region. But we haven't seen a ridge set up over the Pacific to block storm systems. We keep having these little storm systems come in that haven't quite kept up with climatology, but having an above normal snowpack, we can just continue to edge up, and we're likely to do better than last year. But you never know quite what you're going to get just based on snowpack alone. And so on this graph, this is SWE in the Boise Basin plotted against runoff in millions and acre feet. And you can see in 2021, we had almost a normal snowpack. It's almost at 100. That would be your median. But our runoff was around 750,000, which is pretty low. It's one of our drier years. And then if you look at 2022, we had just over 60% SWE, median SWE on April 1st, and yet our runoff was over 1 million acre feet. And that's kind of what helped us recover. It's not average, but it got us pretty close. And that's why the Boise system's recovered from drought. But you can see kind of with those red dots, the last 2 years are kind of on the outer edges of that correlation. So we would call those outliers. And when we look at this year, I've talked about in the past how there tends to be a trend of successive La Niñas being drier. And this is definitely a La Niña winter. But if you look at the snowpack across the western United States, a La Niña should be pretty dry in the southwest and pretty wet in the northwest, and that just does not look like a La Niña. So we have kind of a disconnect between what we're seeing in the tropics and what's happening out in the mid-latitudes of the Pacific where the storm systems come into the western United States. So I think we're going to blow that trend. So if you look at this is the trend of successive La Niñas, and you can see how they all tend to be drier. They're set up in sets. So the first two are black, are two successive La Niñas. Then the next two red ones are two successive La Niñas, and you can see the years below. The only time in our history that just as an average across southern Idaho, and this is all looking south of the Salmon River, was in the early 50s, we blew that trend. And so I think this year, 2023, by the time we get to April 1st, we're probably not going to blow it quite the way we did in 56. But I do think we're going to have above normal snowpack. Already down in southern Idaho on Willow Creek and the Blackfoot, the snowpack is already reached its median peak. And so we're starting to see that trend is likely not to continue for this year. And with that, I'll open it up for any questions related to where we're at from a drought perspective.
Everyone online is muted, so please unmute themselves if they have a question.
Yeah, make sure you unmute yourself if you have a question online. Really appreciate any questions you have of the presenters. It really helps our dialogue.
Hey, David.
Yep.
I was wondering, on that last drought committee meeting we had, we talked about the ground moisture, and it looks like maybe they used that in the latest drought map.
I don't. Yeah, it's definitely, we've factored that in when we're considering water supply. So if you go back to this table here, you can see there's, where it's white, it's within the normal range, but there's a number of forecasts that are in the drier than normal range, shown on the far right. You can see the yellow compared against the white. So the Clearwater, the Salmon, the Weiser, the Payette, those are all looking kind of on the drier than normal side as far as the forecast goes from the Northwest River Forecast Center. So I think we do, especially in the central mountains of Idaho, not so much in the Boise Basin, but a lot of from the Boise Basin upward, it looks like our base flows are really low. And I think that just is a representation that we didn't get good precip in October, and we came out of a really dry period into October. So I think the snowpack is going to get absorbed a little bit in the soils when it melts out, so it won't be quite as efficient as it typically would be. Any other questions? Okay, with that, we'll go to Aaron Wharton with the NRCS. Aaron, are you there?
I'm here. Is it okay? Should I just share my screen?
Yep, go ahead.
All right, great. Okay. Just gonna get rid of some of these little thumbnails and stuff. Okay. Hey everybody, Erin Wharton with NRCS, and I'm gonna follow up on what David had to, David's update on snowpack conditions and some water supply conditions. So first off, let's talk about the water year total precip. I like to keep track of that as well as the snowpack. And just a reminder that we're measuring water year precipitation cumulatively, and we do that by using that brown tall can thing called the precipitation sensor. And then when we're talking about snowpack and SWE, we're using measurements from that lower left part of the photo, the snow water sensor pillow. And this is what one of our snow tell sites looks like in winter. So you can see the precip can captures both snow, rain, and everything in between, while the pillow is capturing predominantly the snowpack and any water that infiltrates in there as rain. So we'll hear a lot more, I'm sure, from the Weather Service on this, but January is pretty dry. So from a statewide perspective, northern Idaho really was the driest. And with the southeast corner, the Willow, Blackfoot, Port Neuf area and the Bear Lake basins being quite wet, and then sort of average in a few basins along the southern Snake basins. The upper Snake was quite dry as well, which is not what we were hoping to see since we need an above average snowpack there to help make up for some reservoir storage. But we saw kind of variation within the Wood and Lost basins. If we look at how dry January was, I like looking at the percentiles. So wherever you're seeing red colors, for the most part, those are below the 25th percentile. So showing that is like an outlier in terms of how dry it is typically in that January. And then those blue colors are showing you where it was wetter, quite a bit wetter than normal, with those yellow and kind of light orange, light blue colors showing where it's, within average. So basically north of the Snake River Plain was quite a bit drier than normal. So on the left, this is looking at our total year water precip, and same thing on the right. So this is looking from October 1 to yesterday. And I've got where we were at our last meeting versus where we are now on the right side. And basically, because that dry January, we overall saw a decrease in these basin-wide water year precip percentages. Like for example, Snake River above high sea went from 104% of normal down to 94% of normal. The Wood Lost basins, we were seeing like 145% down to like 120, so kind of about a 15-20% decline. And then we also saw drying out in the Weiser and the Payette basins fairly significantly. And definitely up north, again, that drying trend definitely affected northern Idaho. And David's map of the western United States kind of showed how the southern part of our state is being favored right now as we capture a little bit of that moisture that's trended towards the southern part of the United States. Moving on to snowpack, same type of thing here. So this is our SWE maps. On our left is from where we were at the last meeting versus on the right, which is now. And in general, we saw a decline across all basins for our snowpack percentages due to dry January. So the good thing that was it was still cold in January, so essentially most of the most of the precipitation came down as snowfall, except for a few places in northern where they had some rain on snow events. But I would say the big picture, when we focus on now, snowpack in general is either at normal or above normal across the entire state, except basically in the Coeur d'Alene and Pend Oreille Kootenai areas. Again, we do want to see certain basins have a much higher than normal snowpack just to make up for these last few dry years that really depleted the reservoir storage. And we'll talk a little bit more about specific areas in a moment. So in January, as I just said, I gotta have myself, snowpack is above normal across all basins, even though we did see declines. Excuse me. We saw sweet gains, which is what this map is showing at basically every single SNOTEL station during January, except for the one red dot, which is Prairie Station, which is a lower station at 4,800 feet in the South Fork of the Boise Basin. But it was good to see, even though it was a dry month, that we see blues basically across the map. Some of it was a little bit more minimal in the lost basins, but in general, we saw decent increases. Moving on to looking at specific basins. So, excuse me, just looking over this gold. Clearwater River Basin, I'm showing the black line is water year 2023, so now. The solid green line is our 30-year middle of the road snowpack, our median snowpack from 1991 to 2020. And then I plotted last year on there for reference. So you can see last year up north, we were actually quite a bit above normal at this time. And now those, last year and this year's snowpack are kind of meeting at that middle average. In general, I'm not showing it on this particular plot, but we do need above normal snowfall in the Clearwater to reach a quote unquote normal snowpack. We've gotten behind enough that we do need heavier snowfall to make up for it. And looking at the 10-day forecast, it looks like we will see above normal snowfall in that region, so that's looking promising. We'll come back to talking about it, but actually, I'll just save something for later to talk about this area. Moving on to the Boise, Payette, and Weiser. This is just looking at these basins and then the SNOTEL sites within them. On the left, we've got the major basins. On the right, we're dividing up into the sub-basins for people who are interested in sub-basins. In general, the snowpack is above normal, so it's a positive thing. We're doing quite well, and given the good reservoir storage in the Boise system, water supply is looking quite promising for the Boise system. Payette Lake is a little bit below normal, and Cascade Lake is about normal, and Deadwood, I actually can't remember. We'll have to look at the reservoir chart here in a few, but basically water supply in these areas are looking pretty good given the snowpack. Looking at the Boise River Basin, so this is very similar to the chart I just showed you for the Clearwater, except that we're looking at projected snowfall and precipitation and where that could end us at peak snowpack. So here again, the black line is our snowpack for water year 2023. You can see that the line kind of flatlined a little bit through our dry January, but we did see about a 1 increase in SWE over the month. That green dash line is our period of record median that we're comparing to. So when we're comparing to normal, it's one of the ways we can compare our current year snowpack. And then that blue line is last year for reference. And then those other colored lines that kind of spray out from this year's snowpack are different projections of what our snowfall could look like and where we might end up being. So for the Boise Basin, since we're really approached pretty close to normal at 108%, we're needing to continue to have normal precipitation to end up at a normal snowpack. If we do get above normal, you can see that we're still going to be within that. We're going to be a little bit above the peak, but it's only about an inch more. So it's not tremendously significant. but this hopefully gives you a range of where we could end up. Even if we get below normal snowpack, that lower green line and that red line, we're still going to be basically above what happened last year. And given our reservoir storage, you know, that hopefully we'll still be okay on there. Moving on to the Upper Snake River. So this is how the snowpack is varying across the different sub-basins and for the whole Upper Snake. You can see that the driest corner, as we pointed out earlier, is in the southeast Portneuf Blackfoot basins at 140, 136%. It's been a little bit drier on the eastern side, especially on the east side of the Tetons, with the Snake River above Jackson Lake at 99%. And those other basins from Grays down to Grays up north to the Pacific, hovering kind of in the low 90s to mid 90s. As we move farther towards the west, those Wood and Lost basins, they really benefited from that early season snowfall. It stayed cold, and it seems like these storm tracks have really benefited that area. So even though those percentages fell from last month, we're still well above normal. And that's really great because they're actually in their fourth year of drought, or they would be. And so it's really nice to see a big snowpack building in that area. So this is the same type of chart I just showed you guys for the Boise River Basin, but for now we're looking at the Snake River above high sea. So including the entire part of the watershed above basically Palisades Reservoir. So black line again is this year's snowpack. Green dash line is our median period of record. And then the lines that are splaying out from the end of where we're at are the projections of like what kind of precipitation we have and where we would end up. So at this point, you know, as long as we're between like normal precipitation patterns, that 50% and 70%, we're gonna end up roughly at a middle of the road snowpack. Let's see if I put these in. This moved a little bit, but if we get below normal precipitation, like that 30%, we'd end up around 92% of normal. So this is looking at that 30% production. And then if we look, and if we look at the above normal, so 70%, a little bit higher than normal, we'd end up around 108% of normal in this basin. So we do need above normal snowpack, and given the low reservoir storage in this area, even ending up at 108% of normal is giving me a little pause about having a full water supply. Kind of depends on what your water rights are, but ideally I'd like to see that even be higher, but it really just kind of depends what the next 2 months have. We have about 60 more days in our accumulation season for that basin. So it's definitely one that, even though we're at normal, I still think we have room to go in terms of making up for the last 2 dry years. Doing quite a bit better in the Wood and Lost basins. I'm just showing 3 of them. They all are pretty similar, where we were sitting in that like 90th percentile, 70th percentile snowpack, and then as the dry January hit, the black line kind of flatlined, and now we're getting into that orange, that kind of light green color, which represents our middle of the road 50th percentile snowpack. So still well above normal, but approaching, kind of closing that gap and becoming closer to normal than where we had been. Still, it looks like, given our stream flow forecasts and reservoir storage, that we will potentially have sufficient water given the current snowpack. Moving farther south. So the snowpack's quite good for these areas, and the snowpack tends to start melting out earlier in this region, just being lower elevation, farther south. They usually start melting out more towards the March time period, so we have about a month and a half left in the snow accumulation season. The snowpack is really quite well in the Bear Basin, and then moving farther westward, it gets a little bit drier, but we are seeing like pretty good conditions for water supply, especially in the Oahe, given though the reservoir storage is quite low. the snowpack seems to be sufficient. If we get adequate runoff, we should see pretty good water supply in that area. It's a little bit less so in the Salmon Falls Basin, although the snowpack is pretty good at 113%. And as long as we get middle of the road precipitation, we'll end up at about an average snowpack. This particular basin, the reservoir storage is quite low that unless we continue to have like a really high snowpack, we could potentially see some shortages for water supply. And this is the same in the for Oakley Reservoir water users, where the snowpack's really good, but it might not be quite good enough to generate the kind of stream flow that we need to make up for the low reservoir storage in that region. Let's see here. So I think one of the big things that is sticking out to me is the difference between like our SWE maps, which are on the left, and then our water year to date precipitation. And David talked about this, like how we had the really hot, dry October, and like the first part of November was dry. And I think that's what's mostly driving the differences between these two maps. But not just for water supply, but other areas where we want like adequate soil moisture and just wetter conditions. This difference between these two maps could play out in a lot of different avenues, I guess, within our state. So our snowpack looks quite good. Our water year total precipitation kind of tells a slightly different story, where it really does point out that northern Idaho is consistently drier than the rest of the state. Moving on to quickly hit up soil moisture. So this is a product that you can find on drought.gov. We've got two different depths. On the left, it's the 20 centimeters or top 8 inches of the soil. And then on the right, it's the top approximately 3 feet. So we saw some changes since our last meeting in that top 8 inches, that 20 centimeter product, where more of Idaho was in the yellow, drier category, and it's moved to this gray color, which is showing like average wetness, so kind of average conditions. We do see slightly different things in other soil products, showing the surface being a little bit drier, but this product is showing improvement in this top surface. What it is showing is on the right, those red colors are showing, especially in central Salmon, Clearwater, and then in the Palouse area, is that we do have really quite dry soils throughout that top 3 feet. So you could call that the root zone. And we could see that playing out in terms of snowpack runoff efficiency, but also folks who are relying on wet soils for dry land farming and ranching practices, or producers. One area that does seem to be steadily improving is that kind of bluish blob in easternish Idaho. We do see that in a couple different products. And then also along the Snake River, more in the Treasure Valley-ish area, both look like the soil moisture has improved a lot. We do see also like red and orange colors over that upper Snake area, suggesting that these drier soils could be impacting our snowpack runoff efficiency come spring. And we'll have to see how it goes, but it's definitely something to keep an eye on. And then I showed this last month. So this is using a different soil product called GRACE. It's a satellite product that measures changes in the Earth's gravitational field, and then uses modeling to attribute where that water is. So we've got on the left, we've got soil surface, then the middle is the root zone, and the right is the shallow groundwater. This is from late last week. And you can see that there is these darker red colors over the upper Snake, and then pretty much through central Idaho northward, suggesting those dry soil conditions are extending both from the soil surface down into the more shallow subsurface. We do see the blues colors indicating wetter conditions along the Snake River plain, and then up in that kind of in the Little Oss area, moving a little bit eastward. And I think I showed this last time too, but when we compare it to the same time period in 2021 where we had that reduced reduced runoff efficiency. To me, it's looking like we have, as a result of these numerous years of dry conditions, that we have overall drier soil conditions, less water in the shallow groundwater systems than we did even 2 years ago. So it's just something that I think we should be aware of moving forward, depending on how spring precip turns out and how quickly the snowpack melts off, that some of that runoff could be absorbed more into these dry soils. So two different maps here. On the left, we've got NRCS puts out stream flow forecasts on a monthly basis. So these are the February 1 stream flow forecasts. And on the right, we've got reservoir storage. And so on the left, looking at stream flow forecasts, you can see that the below normal snowpack, the below normal water precip is impacting the stream flow forecast to be below normal, roughly ranging in the low to mid 80%. We have about normal levels of stream flow predicted in the Boise, Payette, Weiser area, and then in part of the upper Snake, so the Snake above Palisades, and then also in the Henry's Fork Teton. And then in the Henry's Fork Teton, there are some like slightly below normal at 87% stream flow forecast. And then the snowpack really dominates what these stream flow forecasts are based on. So we do see above normal stream flow predicted along the southern Snake basins, definitely in the Bear River, Bear Lake basins, and then through the Wood and Lost. In terms of reservoir storage, which is the map on the right, overall reservoir storage is quite low across the state. This is the percentage compared to normal for this time of year. Anderson Ranch is the Boise system is the outlier in being above normal, but many other places are quite below normal. Jackson Lake's at 29%, and I'm sure we'll hear more from the Bureau here about these different systems. But in general, storage is pretty low for this time of year. So to conclude, big picture, snowpack is near or above normal in all basins south of the Clearwater Basin, and the percentages declined in all basins due to the dry January, but we did see sweet gains, at least at all stations. So we did see some improvement. Some snowpack gains, even though it wasn't much. Compared to snowpack, our total water year precipitation as a percent of normal is lower across pretty much all basins, mostly due to that dry, hot October. And when we compare to the February 2021, soil and groundwater conditions seem drier compared to 2 years ago at this time, and especially in the upper Snake River and central Idaho, which obviously I've been kind of harping on. It could be affecting our runoff efficiency, and then anybody who's using dry land farming or dry land ranching operations. In general, the stream flow forecasts are below normal in northern Idaho and in the Henry's Fork Teton area. They're near normal in the Boise, Payette, and Weiser and upper Snake, and above normal everywhere else. So those Wood Lost basins and southern Snake, Bear Lake. Because of where reservoir storage is, and then given our February 1 stream flow forecast, it looks like water supply could be limited in the upper Snake, the Salmon Falls and Oakley basins at this time. We'll have to see. We still have about 1 to 2 more months in the snow accumulation season, but that's where it's looking at right now. And then reservoir storage is low across the state, and the notable exception is the Boise system. Okay, I think that's it for me. Thank you, everyone.
Thank you, Aaron. Anybody have any questions for Aaron? Aaron, would it be fair to kind of summarize that maybe the snowpack looks a little better than the water supply? In other words, we may not get quite the runoff.
Yeah, I think.
Go ahead.
I find myself in a little bit of a dilemma because the snowpack overall looks really good, but I think because we've had a couple of dry years, I don't feel quite as much optimism as I should, given the snowpack numbers. And I really do think that's kind of a reflection of the dry soils is what, and maybe that's just from the last 2 years haunting me, but I would agree with that statement, David.
Mark, did you have a question?
Hey, Aaron, this is Neil. Hey, I was wondering, when you was looking at that drought map, the comparison between 21 and 23, did you happen to look at 22 and see if it progressively got worse over the 3 years, or?
I didn't compare. Yes, definitely 2022 looked worse compared to 2021, but I didn't look at it for 2023. But I can send an update on that.
Okay.
Or at least I can't remember. I probably looked at it in like too many things.
Right, thank you.
Thank you, Neil.
Any other questions for Aaron?
Yeah, one question here. This is Darren Lettering. I'm an area field officer in southeastern Idaho and attending my first one here. So I don't know if I'm asking the right person this question, but as you see the stream flow forecast that you just had up there, in southeast Idaho, you're thinking about the Portneuf River, and I think it looks like 150% there on is that the Portneuf River? And do you know, or is it you that would answer that or come up with a forecast on what the Portneuf River might look like come springtime and what the melt might look like for that?
Yeah, this is the right group of folks to ask. So that 150 is on the Bear, I believe, and then the 121 is on the Portneuf. Sorry, I might have lost your question, but
I guess I just more directly to that is what does the Portneuf River in Pocatello and Bannock County probably look like for
I'll put that in the chat, and that way I'm just making sure I'm giving you the right number, and I'll put a link to the streamflow forecast in there for you, Daryl.
Thank you.
Yeah, thank you. Appreciate it. The only problem with these maps is like I can't put the names, otherwise they overlap too much, and then I get nervous. So I'm like, wait, am I looking at the right one? But
you put a link to those maps.
Could you say again, please?
Can you put a link to those maps so that like I have a snow water equivalent link that I can just pop up and see what it is for the day, and if I can pull up that map that you're showing there, that'd be great.
Yeah, perfect. I'll put the link in the chat, and then for anyone else, like David will post these presentations, and when you look in the notes for the presentation, I have the links for all the maps too. So any of the figures in the presentation, you should be able to pull up and bookmark. And I'll put the streamflow one in the chat right now. Daryl, perfect. Thank you.
Aaron, this is Mark Zerski with Flood Control District 10.
Hey, Mark.
With the stream flow forecast looking lower, I guess, with 50% reservoir storage, you think it's safe to say we probably will not see any early flood releases before the irrigation season starts?
Ooh,
We'll have the Bureau present on that here pretty soon, Mark. Maybe we can hear from them first.
You bet. Yeah, that'd be good. Thanks.
Yeah, when they present, I think that'd be a really good discussion.
Okay. Thanks, David.
Thank you, Mark. Thank you, David. Okay, I will stop sharing my screen. Thanks for all the good questions, everyone. I really appreciate it.
Yeah, and we probably better go on to the next presentation, but that was great. Thank you very much, Aaron. Troy Lindquist is going to give us an update on weather for the projected outward. And I'm really interested to see what he has to say about the Upper Snake. Are you there, Troy?
I am here, David. Let me get my screen shared.
Awesome. Thank you.
Okay, how's that look?
Looks good.
Okay, So good afternoon, everybody. Just some talking points for my presentation. We'll spend a little bit of time on the recent weather, mainly some point forecasts across this, or some point locations across the state, and see how things have tracked through the water year, and compare a little bit to a last water year. A few slides on La Nina, where we're at, and you probably heard if you've been tracking that, but we're expected to transition to ENSO neutral conditions here over the next couple of months. Then we'll talk about the current forecast. Basically little precipitation across the state for the rest of this week, with just a slight warming trend. And then really for the most part, the second half of the month, the Climate Prediction Center is favoring colder and wetter than normal conditions across the state. So that's good news, especially when you think about last year and that very long dry period that we had. And finally, we'll take a look at the spring seasonal outlook. So we'll start off looking at the Boise airport, see how things have been tracking. The left graph is for the 2022 water year, current water year is on the right. So the bottom two graphs, that's precipitation and snowfall, and you can see this kind of middle one here. We're at 5.91 at the Boise airport, very similar to where we were last year in mid-February, and a little bit less snowfall than we had last year in mid-February. But you can see that last year on the left, how we had this really long dry spell there for nearly 3 months, just really flat-lined, and it doesn't look like we're going to see that this year, so that's good news. Temperature graphs across the top here. This green ribbon, that's our average high and low, the either side of that, and you can see since around Christmas time through mid-January, we had relatively warm period, and then things have kind of gotten back to normal, with quite a bit of variability since mid-January. So moving over to McCall, looking on the right, current water year, you can see how we're tracking at 11.16 inches of precipitation. And on the left, you can see we're pretty close to that as well, maybe just a little bit less than we were last year for McCall as far as precipitation goes. Then jumping over to the Magic Valley, Twin Falls, and I tell you, I look at Twin Falls, it just seems like each year they just keep getting worse and worse. We're at 2.95 inches right now in mid-February, much less than they were last year. They were sitting right around 5 inches, so that's disappointing to see there. Shifting over to the east side of the state, Idaho Falls, just a little bit above that normal curve on the right for precipitation at 3.57. A little better shape there than they were last year at this time. And again, you can see that warm temperature since Christmas through about mid-January, and it got really cold there. Looks like they might even had a record cold temperature there right near the end of January. And one last stop going up north there, Lewiston, you can see their precipitation graph, the middle one on the right, they're sitting right about normal for the water year precipitation. Quite a bit less snow than they had last year. Yeah, last year they were over 15 inches of snow, only 9.2 right now. So looking at our snowpack, this is from yesterday, as Aaron covered, most of the states sitting at normal to above normal for their snow water equivalent, except the northern panhandle region. But you can see those deep purples, anywhere from 18 to 30 plus inches of snow water equivalent at the higher elevations. And you can see lower valleys up around Lewiston, down through the Treasure Valley, through the Magic Valley. Yesterday afternoon, there really was little to no snowpack in those lower elevations. Then I took another screen capture from today after yesterday's system went through, so it did leave some light accumulations across the lower valleys. Overachieved really for the Treasure Valley, I think parts of Boise got 2 to 3 inches, mainly East Boise, further west Caldwell, parts of Meridian got little to nothing. So anyways, kind of an interesting system to come through, a lot of wind associated with that. So jumping over to La Nina, as I said, we do have La Nina conditions continuing across the region. And I like to compare it to these statewide average temperature and precipitation ranks, kind of a coarse scale over on the right, though. So during a typical La Nina, what you see is this colder swath coming down from Canada into the northern tier states. And yeah, you do see that across Montana here when you look at the temperature ranks, not so much for North Dakota, South Dakota. And but you do see that warmer conditions across the Gulf Coast region up towards the mid-Atlantic. Yeah, so just kind of interesting to make these comparisons. I think that precipitation is a little more interesting, and David kind of pointed that out. We aren't really seeing the above normal precipitation across the Northwest. That kind of shifted further south. Seeing that over Arizona, lower Colorado Basin, Four Corners region. So kind of interesting to see that pattern. Ohio Valley is typically wetter than normal. Really not seeing that there either. Kind of normal to a little bit below average there in Indiana for the state. As I mentioned, we are expected to transition to INSO neutral here over the next couple of months. So this graph here is our percent chance of either of these 3 categories. And our x-axis is your 3-month seasons there. So on the far left, you can see this blue bar for the January, February, March 3-month season. So about 63% chance of La Nina. But then we move into the next pair of bar graphs there, that February, March, April. You can see that blue bar really drops off to only about 15%. And the strong indication is that we are going to be transitioned to INSO neutral by February, March, April, and certainly by that March, April, May period, springtime looks pretty certain that we'll be in INSO neutral. And then by the time we continue on our track through the summer, it looks like we even have about a 50-50 chance in that June, July, August period of being either INSO neutral or actually transitioning to El Nino. So it'll be interesting to see how that plays out. So onto the current weather, looking at the satellite image, some features to point out here. We have one low pressure system over the Mississippi Valley area, and the system that just came through associated with that cold front yesterday, kind of a broad trough over the Great Basin, Central Rockies. So you can see that there. And then we have upper level ridge or high situated off the California coast, and that yellow dashed line is just representative of the jet stream kind of going up and over the ridge and kind of diving southeast along the west coast. Then another system that'll make its way to the west coast, just west of that upper level ridge. But that system will be splitting later in the week as it approaches, so we're probably not going to see much out of that by the time it makes it onshore. So I've got some snapshots, 24-hour snapshots here for the next several days. I'm just looking at the 500 millibar pattern. The image here is relative humidity. The darker colors are greens. That's showing the higher humidities, and then the reds and kind of light purplish. That's the drier air in the middle portions of the atmosphere. So this is the situation for midday on Wednesday. You can see there's an upper low or a trough that is kind of situated over the Great Basin today. That's going to be shifting off to the east, and we have an upper level ridge that's going to be moving over the west coast. So we'll step into the middle part of Thursday. You can see that upper level ridge really comes situated over the Great Basin and Northern Rockies, and really that's going to lead to dry conditions for Thursday, Friday, and Saturday. So we'll have little to no chance of precipitation across the state. Then that system I pointed out that's currently over near the Aleutian Islands, you can see that just off the west coast. And if we step into Friday, that system splits, and our upper level ridge that was over us is going to shift over to the east. So that splitting system, not going to see much out of that, but just a gradual, very slight warming trend as we move into the latter part of the week. Then from Saturday into Sunday, you can see we get into a northwesterly flow, and our chances of precipitation will start to increase by Sunday and certainly into Monday here as we start to see some moisture in that northwest flow and actually start to trend our temperatures back down. This will be interesting by the time we get into Tuesday, then jump ahead to Wednesday of next week. We have pretty decent model agreement of a pretty cold weather pattern setting up across the area, increasing chances of precipitation. So looks like next week, after a slight warming trend heading into the first part of the weekend, we'll be trending back down for temperatures and seeing kind of an active weather pattern with more chances of snow next week. So that's good news. 7-day temperature forecast. Just look at a couple points here for Boise. You see for tomorrow, we're looking at about 41 for a high. And as we head into the weekend, we'll see a gradual warming trend, then start to trend back down as we get into the early part of next week. Similar for Twin Falls, Stanley, not going to see as much warming with some colder air, just kind of harder to get scoured out of that area. So for the next 5 days, precipitation total from the Weather Prediction Center, just not too much. There'll be a little bit of lingering precipitation. It looks like maybe tonight and tomorrow as the trough currently over the area pulls away from the region. But Thursday, Friday, Saturday, like I said, look quite dry across the entire state. Then by the time we get into the weekend, we'll start to see some change in the pattern with chances of precipitation. So the 7-day total, this catches the second half of the weekend into the early part of next week. So Sunday, Monday, Tuesday time frame, that's where most of this precipitation is showing up from. So you can see it looks like maybe up the Clearwater, the Snake River headwaters, some areas central, northern, and far eastern Idaho have the best chances of seeing significant precipitation. 6 to 10 day outlook from the Climate Prediction Center. As I mentioned, this is primarily next week. You can see broad area of the western U.S. for pretty decent probabilities of seeing below normal temperatures and above normal precipitation, especially over the northern Rockies for the above normal precipitation. And shift into the 8 to 14 day outlook, again, below normal temperatures, pretty strongly favored over the northwest and all of Idaho, with pretty decent probabilities that we'll see above normal precipitation during that period as well. So again, second half of February, unlike last year, looks more favorable here with colder than normal and wetter than normal conditions favored. And finally, for that spring outlook, with that transition to ENSO neutral, there's not a lot to go on as far as indicators, what our climate might look like during that March, April, May period. So just a very slight lean towards below normal temperatures for the kind of the northern third of the state, and equal chances for either normal or above normal or below normal precipitation across the entire state during the springtime. So that's my last slide, David. So any questions they might have, I'd be happy to talk about them.
Any questions for Troy?
Just one.
Go ahead, Steve.
Troy, I saw a piece in the Capital Ag Press last week from a weather expert talking to some ag groups that were saying, he was saying once we move away from La Nina, he's seen a huge high pressure ridge camping off the west coast and shutting off moisture for 2 or 3 months. I just wondered if that squares with your understanding.
Well, yeah, that's possible, but I think right now, looking at this, seasonal precipitation outlook, this is based on transitioning back to ENSO neutral. And if you look at our precipitation chances, we have equal chances of, either of those categories, normal, above normal, or below normal. So I don't think we're seeing, or climate experts are seeing anything that would indicate no or very little precipitation at this point. There's just the indicators aren't pointing to drier than normal conditions. So that's why we have that outlook and equal chances.
Thank you.
Any other questions for Troy? Well, I like that precipitation up in the Snake. That would be great. Let's hope we get it. Okay, we'll go on to Jeff with the Northwest River Forecast Center. Jeffrey, are you on?
I'm on. How you doing?
Good.
That's, hopefully you guys are seeing my screen.
Yeah, we
not
see your
my,
screen.
Okay. All right. Hello, and thank you for having me today. My name is Jeffrey Walters. I'm with the Northwest River Forecast Center. And so we are part of the National Weather Service. We work with Troy and other weather forecast offices throughout the Northwest. And we provide both short-term 10-day river forecasts throughout the Northwest, but we also provide seasonal water supply volumes throughout the Northwest. And today I'm going to focus on the latter, our water supply volume forecast for the state of Idaho. And I just want to point out we have an email on there, the Northwest River Forecast Center, watersupply@noaa.gov. That's a good place if you ever need to reach out, if you have questions about our products that I'm going to talk about today, and kind of the context behind what those products are saying. If you ever have questions that aren't addressed in this meeting, feel free to reach out. We're always happy to help people better understand how to use our tools and this kind of the things that we present on our website. So I'll just go through the take-home messages first, what you guys can expect. Overall, I'm going to be focusing on our April through September water supply volumes throughout the state of Idaho. And generally, the water supply volumes that we're projecting for this year are 80 to 95% of normal throughout the state. Thus far, our currently water year precipitation in southern Idaho has been near normal. That's kind of been well covered in previous presentations today. And I guess the model snow states reflect this. I guess I should give some context there. A lot of times I'm going to be talking about the hydrologic models we use to produce our forecasts. And so our hydrologic models have a snow model, which models snow accumulation and melt off. And currently the snowpack in our snow models in the state of Idaho reflect that near normal precipitation of accumulated snowpack. Then up in northern Idaho, we have slightly below model states. And both of these, the model states, and I'll get into this in subsequent slides, would drive kind of our water supply forecast. More on that later. But the northern Idaho, I think, has been covered before. It was really dry last month in January, but it's still, the snow states are near normal, and that really a beneficiary of the cold, wet November, December we saw in the state. Now, in regards to observed runoff that we've seen seen this year, it's below normal, I guess. And this kind of is a good indication of what current base flow is in our model, our soil states, another hydro model component. So those are below normal. So it's kind of, I think, the overall picture with our water supply volume forecast is that though the snowpack states are near normal, what's kind of driving those water supply volumes to be below normal is those drier soil states. So you can kind of think of it as the dry soil states means that there's a deficit that needs to be in those soil states that needs to be addressed with the melt off before we kind of return to a normal river conditions. So those are kind of dragging those water supply volume forecasts down to that below normal despite the near normal snowpack. So really right now, because of those dry soil conditions, the ensembles that are part of our, I guess, the indicators of our water supply volume forecast, most of them are showing that, there's at least a 75% chance that we're going to have a below normal April through September water supply volume. I wasn't expecting to spend that much time on that slide, but I think that was good. Anyways, I got the cart before the horse there. So let me just kind of talk what makes our water supply volume forecast unique, and why I'm spending so much time talking about hydro models is that we produce water supply volume forecasts for a variety of periods. But today I'm going to focus mostly on April through September. And we issue a water supply volume forecast every day. And I'll just kind of walk really quickly through how those are produced on a day-to-day basis. So as I mentioned before, we have our hydrologic models, through hydro models, and those hydro models have both a soil and a snowpack component. And we're actively tuning those hydro models so that those snowpack and soil moisture conditions represent on-the-ground conditions. So we're constantly tuning the current states of the hydro model. And then we'll run our hydro model for the first 10 days driven by the by weather forecasts. So whatever, like Troy was saying earlier, whatever the 10-day outlook is for precipitation and temperature is going to drive these hydro models that produce stream flow throughout the state. And then, then beyond those 10 days, we have our seasonal ensemble forecasts. So really, beyond those 10 days, we drive our hydro model. We run it for each water year since 1981 to 2021. So roughly 40 different ensembles that we force the hydro model beyond those 10 days using precipitation and temperature pairs for that. And from that, we summarize those ensembles as a box and whisker plot, and we plot those every day on our main water supply page for a site. But you'll see that here in subsequent slides. But I guess the main takeaway is that really day to day, when we produce a water supply forecast, the current states in our model and the 10-day meteorological forecast are really going to drive day-to-day changes in how our water supply volume forecast. And then the ensemble members really act as a building a range of possible outcomes in those forecasts. So anyways, out of the weeds, here we go. Seasonal precipitation. So this is kind of just another way to look at seasonal precip that we've seen throughout the state at 2 points. One is above American Falls and one is above Lower Granite. Above American Falls, you could kind of think of as the upper Snake, and then the above Lower Granite would be the entire Snake River Basin, and the upper Snake portion above American Falls. Thus far this year, we've got on the x-axis the date and the y-axis the accumulated precipitation we've seen above that in that upper watershed, and you can see that it's tracking pretty close to that dotted line, and that dotted line is the 30-year average. The blue and the dark blue line is the current water year. You can see it's pretty close to normal, and actually it's 90% of normal as of yesterday. And it's doing better than other water years in the past 3 years. And then on the Snake River Basin, it's a little drier. It's quite a little drier. It's not at normal. It's below that dotted line, so it's 80% of normal as of now. So we're seeing near normal up in the upper Snake, but overall in the Snake, it's below normal precipitation thus far this year. So going on to the next slide. So looking at the precipitation, we've seen this far, and then this is looking at stream flow we've seen thus far through this water year. So that would be October 1st through February 13th. And this isn't exactly the runoff you would see if you were to check a USGS gauge at any point shown on the map. Instead, what it is it's adjusted runoff. So it accounts for any upstream storage from a reservoir. So it's quasi-naturalized runoff. So overall, the naturalized runoff throughout at select points throughout the state, I've got eight different locations here. You see that the runoff thus far throughout the state, the naturalized runoff is below normal, quite a bit below normal. And what that's kind of indicating is that it's a memory from the last subsequent years or the previous years, dry runoff drought conditions, that the soils are a little bit drier than normal for this time of year. And, base flow is down, typically for most of the state. This October through February 13th period, you're mostly just seeing base flows. Rivers don't really get active until the springtime when snowmelt starts running off. So it's just really carryover from last year's drought, last few years' drought conditions. And that's going to kind of another indicator of drier than normal soil states. So going over another component that our water supply forecast kind of drives our water supply forecast. This is the 10-day precipitation. So all of our ensemble members, are driven the first 10 days using this 10-day precipitation. You can see on the left is the 10-day totals at portions throughout the state. So red and blues, that's pretty wet, up to over 4 inches for over the 10-day period. And then the lighter greens and white would be less precipitation. You see up in the northern part of the state, we're seeing quite a bit of precip predicted over the course of the next 10 days. The same goes for the upper Snake. And then the plot on the right is that map. If so, how different is that from like normal precipitation we expect this time of year? So a 0, white values would be its precipitation exactly at normal precipitation conditions for this time of year. Green would be wetter than normal. Yellows and reds would be drier than normal. You can kind of see it's a bit of a mix throughout the state. And the amounts are quite small. Maybe it's a half of an inch wetter than normal over the course of 10 days, which isn't a whole lot, or drier by 0.75. But I would say overall pretty close to normal precipitation conditions expected over the next 10 days. So we kind of gone over, precipitation has been near to, as it's been spoken to in previous slides, the snowpack is near normal. Soils seem to indicate that they are drier than normal. Those two things competing, the April through September water supply volume forecast at most of the state is still below normal, despite that near normal snowpack. And again, that's kind of probably most likely the soil condition, drier than normal soil conditions, which we can see with the below normal base flows currently are as an indicator that are kind of the reason why our forecasts are still showing below normal April through September volume. To put it another way, we're really going to need to see more SWE accumulation that gets to the level of, not near normal, but something well above normal to really kind of overcome that soil moisture deficit. Okay, next slide is, okay, so this kind of goes back to that slide several slides ago where I was kind of talking about how our forecast is made. You can see on the right side there are a succession of box and whisker plots. And each one of those box and whisker plots is a day's issuance of our water supply volume forecast. So like I said before, we issue water supply volume forecasts every day. And you see the x-axis is actually the day of issuance. So you can kind of track, what this is doing is you can kind of track the progression of our water supply volume forecast. The y-axis is the seasonal volume for April through September. You can see on, October 1st, we're kind of starting at near normal conditions. And then as, we get progressed through the water year, it's, the model, the snowpack accumulation and the soil states as they change through the water year due to the seasonal conditions, kind of our water supply volume forecasts are reflected by that until you get to the right-hand side there, where you see the the most recent issuances in February, and this is our below normal at this site. And how do I know they're below normal? Is behind those box and whisker plots is a green line. I don't know if you can see it on the right hand side, but that is the normal water supply volume forecast for this site. And this site is the Lower Granite Dam, which is again pretty much encapsulates the entire Snake River Basin. And you see, right now the water supply volume forecast for the Snake is below normal based on the box and whisker plot. You see the red line is the median value, and I guess I should say it's below normal. The median value is below normal, which is the red dots. But it's a box and whisker plot, so it's kind of encapsulates the information and all the ensemble members that are ran. And so you can see there is the whisker part, which is the line part of the last issuance, does have some ensemble members over 50%, but the majority of the ensemble members are below that normal line. So I'm going to show you kind of the breakdown of how that runoff is going to look, expected to look month by month. Again, more box and whisker plots. So those are basically information contained in the ensemble members of that water supply volume forecast that was issued yesterday. The green dot is normal, average for that month. Y-axis again is volume, so that's the monthly volume, and the x-axis is each month. So you can see maybe the way to look at this is how that green dot is in comparison to that box and whisker plot. If it's in the interquartile range, which is the yellow, it's kind of in the somewhere in a more closer to normal outcome. And if it's on the whisker, maybe it's more on the extreme end. And you can see, that for March and April, the ramp up to the melt off, maybe closer to normal. And really the month that you could say that's hit hardest by this below normal water supply volume forecast is the month of May. So this is just for Lower Granite Sand. I would like to kind of circle back to the other sites that we went over earlier and kind of show the same information, but maybe condensed. So I'm just going to go backwards real quick. The first thing I want to show is this median value. So this is kind of like the median value of all the ensemble information. That's the red dots. So tracking that for the sites we talked about earlier. So how that's tracked through each day of issuance. So that's the first thing I want to show. So here, that's a lot of lines here, but I can talk you through this. So again, the x-axis is the day of issuance. So, October, November, December, January, February. Those are the day of issuance. And then that median value, each day of issuance, just tracking on the y-axis what percent of normal it is. So like if we look at Boise at Lucky Peak, which is the brown line, and you really look at I don't know if you can see my mouse, but if you could see the mouse right here on like the February 2nd issuance, if we were to look at that, the median water supply volume forecast said that it was going to be an at normal volume forecast for April 1st. But since then, since we've issued water supply volume forecast, since then this line has dropped, saying that the water supply volumes, as the dry conditions have continued, that water supply volume forecast has dropped, and now the last issuance as of yesterday was probably around for the Boise Basin. The medium forecast was saying it was at 90% of normal. So this is showing, you can kind of track how this has changed for each one of these sites through the water year. And really, I think the big takeaway is you can see how our water supply volume forecasts have kind of really dropped since the beginning of the calendar year. Almost all these sites, these are all different water volume forecast sites. All these sites, the water volume forecasts have water supply volume medium forecast has dropped over the last month and a half. And that's really because of, those dry January precipitation conditions, that they've kind of, as we get further into these really important snowpack building months of January, the fact that it was so below normal has impacted our water supply volume forecast that, some more than others, but really, kind of got us to any gains that we made in December, kind of got us back to where we were prior, and that a lot of spots throughout the state are back to the 90 to 80% range. So I'm going to take a leap and go one step further. We'll see how this works. So I'm going to go back to here. Again, we have the green line, which is the our normal, the 30-year normal April through September volume forecast. So the next thing I want to know is for each day of issuance, what percentage of the ensemble members are above or below that line? And so that would tell us what the chance of it exceeding normal conditions are for each day of issuance. So hopefully this helps kind of, okay, so see if this works. Trial and error here. The, what we're looking at here is basically the chance, is there a 50% greater chance of having a normal April through September water supply volume on each day of issuance? You can kind of see that pretty much tracking through the entire water year, we've been kind of, the water supply volume forecasts have kind of indicated that there's less than a 50% chance that we're going to have normal water supply volume forecasts through April through September. And really, unfortunately, because of the dry January, that chance has only gotten worse. And now we're, for most locations throughout the state where we're sitting at right now is only like a 25 to 30% chance of hitting normal water supply volumes for April through September. So it's going to take, like I was saying before, probably going to take an improvement in the snowpack conditions where we see not just at normal snowpack come April, but well above normal conditions to kind of get to a point where there's a chance that we would overcome this and get to a normal water supply volume forecast. And in the interest of time, I'm going to skip that and just kind of go over one more time everything I just said. April through September, the water supply volume forecasts are generally 80 to 95% of normal. Precipitation has been near normal, and our model states, kind of both in the northern and southern half of the state, are near normal. But really, kind of what's driving that water supply volume forecast is that drier soil states. Those dry soil states really have to be overcome before we can kind of get back to normal river conditions. And it's generally looking, the forecasts kind of generally point to not a great chance that we're going to get to normal April through September water supply volume, but probably be in the 80 to 95% range. So that's all I've got. If there's any questions, all right, I grabbed this. We can talk about that if you want. That's all I got.
Thank you very much, Jeffrey. That was a very informative presentation. I noticed that when you look at the NRCS forecast, they're generally across the state are just slightly above normal. They seem to be tracking the snowpack, and your guys' are slightly below normal. So, Aaron, I think you mentioned your concern about the drier than normal soils. If you were recommending people following the forecast from the NRCS, would you suggest maybe looking at the 70% exceedance?
That's what I'm trending towards recommending. Yeah, we definitely have these debates because we compare our stuff to the River Forecast Center at the beginning of the month, and we're like, we're a lot wetter. And I think the Forecast Center does a better job of integrating like the soil moisture conditions and things like that than our current models can. So I feel like a little nervous. I mean, like it's a little early to say, yes, use the 70% exceedance forecast, but it does seem like it would be the wiser, more conservative decision.
Well, hopefully we have a really wet spring and we moved to the other side of the forecast. We'll see.
That'd be good.
Heidi,
Yeah,
do you have a question?
So this is a question to either Aaron or Jeffrey, but I'm just curious about your sense for how, like which period prior to a given moment affects the soil state. So how far in the past does it affect the current soil state?
Take a swing at that. I would say, I mean, this isn't a cop out, but it really depends basin to basin. I think the wetter, just generally, I mean, this is generalization. The wetter the basin, the shorter the memory. I think is the easiest way to say that. In the southern portion of the state where we get some really dry, you have some really drier basins that see less annual precipitation. That memory is longer. But for a wetter basin that sees more annual precipitation, that memory would be shorter. But again, it's that is a generalization, but I think that's maybe the most succinct answer to your question. Aaron, feel free to take your swing.
I only have arm waving, so that was a great job. I don't know. I'm still learning about that, Heidi. I'm not sure. One of the kind of things that I've heard since starting this job 2 years ago is that it really depends for us in terms of how the soils are going to impact us. It really depends on what happens in the fall. So if we get those wetter conditions, we get more saturated soils, and then it leads to better runoff efficiency. And like this past year, we had dry soils, and then it just got cold and it froze, and then we got snowpack on top with less infiltration. I'm not sure if that's kind of what's getting at your question, but right now that's sort of the way I'm thinking about the shallow soils. And then if we look deeper into the groundwater system, I think that's kind of more of a multi-year process to see the weather declines in the shallow groundwater and how that affects stream flow. Something I'm learning more about.
Yeah, thank you.
Based off Aaron and Jeff's comments, I would say, comments, I would say in northern Idaho, the fall precip is probably not as critical, but in southern Idaho, it tends to play a bigger role. So those, like Jeff is saying, those dry soils, the memory's a little longer the further south you get. Any other questions for Jeff or Aaron? Well, we probably better move on. I'm not going to give you much time. Got to strike fast there. So we'll now move on to Jeremy Dalling with the Upper Snake. Jeremy, are you there? We can see your slides. Thanks.
David, can you hear me all right?
We can hear you well, too.
Hello, everyone. My name is Jeremy Dowling. I work for the Bureau of Reclamation out of the Upper Snake Field Office. I'm going to give an update on reservoir operations and water supply. Kind of an overview of my presentation today. We're going to talk about storage conditions and then as well as natural flow, and then our updated forecast for the month of February, and then some other details about the basin to help us kind of give an indication for what type of water supply we may be looking at. So I wanted to begin my presentation today just by orienting ourselves to the area of focus for my presentation, which is the Upper Snake watershed above Milner Dam, essentially. Just some of the details about this basin that make it unique are that it's a fully appropriated basin, meaning that there's more demand or right for water than there is actual water supply for most of the year. Within the Upper Snake watershed, there's 9 reservoirs that have a combined active capacity of just a little under 4.2 million acre feet. Within the water right accounting program, just an interesting note here, there's 345 points of diversions that are monitored. Additional facts, there's over 1,100 water rights or natural flow rights. During peak irrigation demand in June and July on a given day within this basin, just for reference and magnitude, we see upwards of 50 to 60,000 acre feet per day of consumptive use. And then just also noting that of those 9 reservoirs that were mentioned, 2 of them are privately owned and operated, being Henry's Lake and Milner Dam. So on this slide, giving an overview of storage conditions within the basin. So on the bar charts at the top of this slide, I'll just mention here that the gray bars represent parameters that combine reservoir storage for that upper Snake Reservoir System parameter. That's looking at federal storage above Milner Dam. Currently, that parameter as of end of day yesterday was at 43% of capacity. That's 66% of average. For the above high C parameter, that's looking at combined storage above high C in Jackson and Palisades. Those 2 reservoirs combined can store a little over 2 million acre feet. We're currently at 25% of that capacity, which is 43% of average for the date. Palisades Reservoir individually is at 28% of its 1.2 million acre foot capacity. Jackson Lake, 21% full. On the Henry's Fork, kind of our all-star at this point in time, coming out of last year, currently those 3 reservoirs, being Henry's Lake, Island Park, and Grassy Lake, are at 82% of their capacity, which is 101% of average. Riley Reservoir is sitting at 57% full. For the lower system parameter, that's looking at combined storage in American Falls and Lake Walcott. Combined, those 2 reservoirs can store just a little under 1.8 million acre feet, and we're currently at 57% of that capacity, which is 81% of average. Some of the notes I'll just mention, the bottom of this slide contains a table. Most of the information has already been shared verbally, but one thing I will note on the right side of the table, on the far right column, just noting the year-over-year differences in storage. So noting here that the Upper Snake Reservoir System total storage is about 95,000 acre feet lower than last year on this date, and how that kind of partitions within the basin is that above high C, we're just a little over 19,000 acre feet fuller, but in the lower system in American Falls and Lake Walcott, we're about 110,000 acre feet lower. So that's kind of how it's partitioned across the basin. Compared to last year, we have a little bit more storage upstream in the headwater reservoirs, and then a little bit lower overall in the lower system. So now to look at a time series plot of total system storage. So on this figure, what we're looking at is storage in acre feet on the left axis. I'm looking at federal storage above Milner Dam. So each of these traces on this figure represent analog years, with 2023 or the current year being represented by the blue trace. And then the red dotted trace represents last year's conditions, water year 2022. And also included on this figure, the green trace is conditions or total storage that were observed in 2021. And then each of these shaded regions just represent the statistical ranges for the analysis period, which goes back to 1977. So some of the highlights I'll just mention here again is noting that we're about 95,000 acre feet lower than last year at this time. We're still trending right near that lower decile for that analysis period that we've been in. Some of the years that were lower than this year within the period of record include 2002 and 2004. So within the last 30 years or so, we have been lower, but we're still in the lower decile overall. And that's kind of where we're seeing, and you can note the trends of the traces as they represent how the reservoir system behaved in prior years, as well as how we're currently filling. And then just noting over the last week or so, the reservoir system has been accruing physical storage at a rate of just a little under 9,200 acre feet per day. So on this slide, same layout, similar type analysis for that above high C storage parameters, looking at Jackson and Palisades storage combined. Some of the notes I'll just mention here is how similar our storage has been in those 2 reservoirs compared to the red dotted trace, which represents last year. For this parameter, we're also in the lower decile of historical period, and then also noting that for this parameter, the period of analysis extends back to 1958, which is essentially when Palisades came online for operations. So a little bit longer period of record compared to the prior slide, but just noting here we are in the lower decile for storage above high C at this time. Additional notes, just we're right around 19,000 acre feet fuller year over year, and you can see how the blue trace has trended compared to last year's trace. And then over the last week or so, those 2 reservoirs have been gaining physical storage at a rate of just a little under 2,200 acre feet per day. So then similarly for the lower system, focusing in on American Falls and Lake Walcott storage combined. Some of the notes I'll mention here is that we are sitting relatively better in the lower system at 81% of average conditions, but year over year, we are 110,000 acre feet lower than last year, and that's typically how we operate the system. We try to maintain as much as we can in the upper reservoirs. That gives us the flexibility to move water down as needed during the irrigation and delivery season. That's a part of system function that keeps the system healthy. So just some of those notes that I'll mention here is that we're also in the lower decile for this parameter, but a little bit better overall, and currently filling at a rate of just a little over 6,700 acre feet per day in the lower system. So essentially the very same information was shared previously by Jeff, but on this figure, what we're looking at again is that observed natural flow condition at different points within our basin. So on this figure, the black arrows indicate kind of points within the basin that are of emphasis for us as indicators of reservoir operations and water supply. So just noting on the right side of this figure, that 87% of natural flow observed conditions since October 2022 through the current date, that represents essentially the natural flow above Palisades, as close as we can approximate it at this time. And then also noting towards the upper part of the figure, if you guys can see my mouse, that arrow pointing to that indicator of 84% of normal conditions, that represents essentially natural flow as calculated at the Rexburg gauge to kind of give an indication for what base natural flow has been on the Henry's Fork, 84% of average. And then finally moving down to the bottom of the watershed, the arrow pointing to that 77% of normal conditions for an estimation of natural flow above Milner Dam. Very important parameter to kind of context what we're going to be looking at for the remainder of the water year. Essentially that represents or is an indicator of what type of storage accrual into reservoir accounts we've seen so far for the water year, about 23% below normal. So on this slide, I'm giving an update on Reclamation's Upper Snake forecast. So on the top table, that represents the forecast that were prepared and presented on January 1st. And then the bottom table represents the updated forecast on February 1st. Some of the things I'll mention here is that as of February 1st, our operational forecast for February through July runoff above high C, which informs Palisades and Jackson operations, came in at 98% of normal. Month over month, that's about a 5% drop in forecast. Some of the other places that I'll highlight is that the Jackson Lake forecast was updated to a 94% of average runoff, which is a drop of about 10%. And then also indicating also of interest here was the Littlewood forecast, which came in at 129% of normal forecast for February through July, which is a relative increase from January of about 8%. Then again, another point that I think is kind of gives great context for what type of water supply we may have for reservoir operations this year. This is a little bit different. This is a different location that was shared by Jeffrey earlier. This is that natural forecast at the Milner point in the basin. And primary reason for sharing this is just to give some context for what we might see watershed wide for natural flow above Milner, as we know that's an important component to water supply. And the key point here was that that range is about 71 to 127% of average. And that's going to factor into the conversation later in my presentation. But even at this time, reasonably at this time, there is still a large amount of uncertainty. And the uncertainty being represented here is upwards of 2 to 2.5 million acre feet in the forecast range. So this is a figure that we've been sharing in a few of our presentations just to give an indication for, what type of indexes we might consider appropriate for water supply. Again, this was a figure that what it is essentially doing is it takes carryover storage and then factors in the calculations for stream flow in that given year. And then it summarizes it over this analysis period, and we kind of partition out years that there was a 100% allocation of storage supplies, and that's kind of highlighted by this green shaded region. And that's kind of what we're targeting or hoping to get to for a full water supply, recognizing that water supply is not equitably distributed across the basin. And some canals have very good storage supply that may be able to get through multiple years, whereas other canals are more reliant on natural flow. And once the natural flow is gone, if they don't get a full water supply allocated for storage, they end up shutting off in August or earlier. And again, we shared this in prior presentations, but what we're looking for or would like to see, I guess, in order to get to this full water supply level would be about 120% of normal natural flow above Milner. Currently forecasting below average natural flow above Milner. And to give some additional context for some of the uniqueness of the Upper Snake, this is a summary of what allocations were made in the Upper Snake in 2022. Some of the points that I'll just mention is that kind of the background or backbone of all this is prior appropriation. So essentially each of these reservoirs have a storage water right that's based on prior appropriation. So therefore you have a more junior water right. That's beneficial. Also recognizing that your proximity within the basin is important in regards to what basin yield is available to your water right. So typically the Jackson Lake accounts, those are very early water rights, with the earliest being a 1906 right. So for last year, those shareholders received a 92.7% allocation. And then just to contrast that with what the Palisades Reservoir accounts received last year, where on paper, those shareholders that have contracts for water in Palisades only received a 52% allocation of that water supply. Then also highlighting here that the Ryder Reservoir accounts or Mitigation Inc.'s accounts only received a 12% allocation last year. And then American Falls Reservoir, obviously one of the earlier reservoirs that was constructed, also situated lower in the basin. Those water users received almost a 95% allocation. And then Lake Walcott, those water users received 100% allocations. And then also recognizing that many water users and contract holders have contracts in multiple reservoirs. But just to kind of give this group some context for how paper allocations are different than physical storage, and then also, what type of allocations we may see for this year, recognizing lower storage year over year, and then forecasts that are not exceptionally different from last year. So moving into this slide, I've shared this previously in presentations as well. And so what we're looking at here is similar to the plots that the NRCS shares, where we take observed conditions and we project out historical analog deltas or changes in parameters. And the point of this slide is not necessarily to show that system storage can be depleted all the way to zero, but it is to give some context that unless we see conditions like we saw in 1993, essentially we're looking at another year of rationed water supply, recognizing that carryover storage is a mitigation tool against future drought. So there's enough demand and need for water that by right, the system could be depleted. But if we were fortunate enough to have a very wet, cool year, such as 1993, the point of this figure would be to show that if those conditions were observed, there would be some chance of receiving a full allocation or essentially filling the reservoir system around that July 1st period. So to kind of characterize what type of conditions we would be looking for to help improve our water supply, this is looking at a parameter that estimates the consumptive use above Milner on a given day. So each of these traces, the red trace represents an estimate of daily system depletions above Milner for water year 2022. The green trace represents water year 2002 for the same parameter. Then that blue trace, which corresponds to the prior figure that showed that 1993 year, which was a very unique year, also included in this analysis just to give some context. And then this black line represents the running 30-year average. So characteristically, what we would see, or like we recall last year, coming into the spring, for water supply considerations, cool, wet spring, lower than average system depletions. Basically, in 1993, it was too cold and wet to even plant crops, and so there was very little consumptive use. Whereas in 2022 and 2002, water users recognized they were going to be short of water, and so they rationed water supply. So different motivations for why diversions were low in the spring, and not forgetting that 2002 was also a wet and cool spring. But those type of conditions were really beneficial for water supply in those years. And then just noting here that once we get into that peak irrigation demand about that first couple weeks of July, we still do typically see consumptive use across the basin get up into that 50 to 60,000 acre foot range for a daily consumptive use across the basin. And then from that point, and at that time, we will have seen our day of allocation, which is when allocations like the ones that were shared previously are determined. And at that point in time, irrigation districts and canal companies they know what kind of storage supply they're going to have for the remainder of the year. And in 1993, they received very good allocations, and that's why you see diversions remaining mostly above average throughout the remainder of the irrigation season, whereas in 2022 and 2002, we see very clearly that diversions were not near average for that period, as irrigators obviously ration demands in order to make it through the irrigation year. So that's the type of characterizations of water supply that may be beneficial into the springtime period. And then once we get into July, this figure just kind of highlights how different water supply years play out during that very critical time for crop production. At this point in time, quick summary, operations have not changed. For the winter, we have a lot of reservoir space to fill, and forecasts are not exceptionally high at this time, are indicating that they will increase significantly. For this time, we are releasing 280 CFS from Jackson Lake, about 900 CFS from Palisades. Henry's Lake is at 0, Highland Park's at 225, Ryrie's at 0, American Falls is right near 300 CFS, and then downstream of American Falls, Minidoka is releasing 425 CFS. That 425 plus reach gains becomes the natural flow that is available at Milner, which is currently being diverted for recharge under natural flights or passing Milner under the interim agreements that are in place there. Littlewood also at 0 CFS. I would highlight that Littlewood has a very good outlook at this point in time, with its forecast being 129% of average. If that forecast hold, we would be able to fill the reservoir and potentially have an opportunity to regulate fill there as well. So good outlook for Littlewood, especially relative to the other parts in the basin. Some of the analog years that we're seeing include last year's conditions, as well as 2014, 2005, and 2002. And that's all I had for today. Be happy to take any questions that you have, and our contact information is also on this slide.
Any questions for Jeremy? I thought that was a really good presentation, Jeremy. I liked how you pointed out in that one graph that the water supply is not likely to be adequate for the irrigation season without some kind of rationing, although a 1993 type of year could come along. Any other questions for Jeremy?
Okay, thank you.
Thanks, Jeremy. We'll go on with Ryan Hedrick for the Middle Snake. Ryan, are you there?
You bet.
Yeah. We can see your slides and we can hear you.
Perfect. I'm Ryan Hedrick. I'm with Middle Snake Field Office in the Water Operations Department. I'm just going to go where we currently stand with our reservoirs and what we could possibly see happening. Right now, we're at 57% of capacity. We're still at minimum flows at both Anderson and at Lucky Peak. Anderson is 300 CFS and Lucky Peak is 250 right now. Arrow Rock is currently cycling flows for power production at 150 CFS daily average. Our Boise system storage content as of yesterday midnight is at 544 CAF, which is 109% of average. And our forecasted volume, this is our February 1. Oh, this should be changed. It should say February 1. Sorry. It's February 1 to July 31. And our forecast came in 1.55 million CAF. So this is the forecast that I used on some of these modeling results that I'll show you. And as we know, it's most likely gone down quite a bit from there. So some of these results you'll have to take. You'll just have to understand that it most likely isn't going to head this way unless we turn around, like Jeremy said, and got a really good wet spring. So this is the Boise system modeling results that we have, and what it done is forced 101.55 million calf through the system. And what it shows you, basically what this graph is showing you, that if we had that volume, it would be likely that this is the outflow. So we would likely see some flood ops. But as that forecasted volume goes down, a lot of this starts to get cut off, and you may not see any FRM, flood risk management. Same with Anderson Ranch. Most likely all the numbers I ran through Anderson Ranch. I will say I did run some other forced volumes, and as we got below 1 million, things were starting to look a pretty not real good. So hopefully we keep that forecast up. Anderson Ranch, having water, a whole bunch of water in the system up there, will likely fill. We would likely see some, I don't know if we'd consider FRM at that point, but you'll likely see some higher flows early on, maybe in March, April at Anderson Ranch. And then at Arrow Rock, this storage can change quite a bit. The black line is the storage. Oftentimes you'll see this one dip down to create a hole to catch some of that water that's coming down from Anderson. And then Lucky Peak again, this is going off of higher forecasted volume. And I need to point this out. This is all actual back here. This is when our model starts simulating what's possibly could happen. So with the higher forecasted volume, we were seeing some early releases, but at this point we aren't seeing that right now, but that could change. Moving on to the Payette. The Payette is 59% of capacity. We are still at minimum flows at Cascade at 200 and Deadwood at 50. The Payette system storage content is 470 calf, which is 93% of average. And our forecasted volume, again, I should say February 1 is 1.663. And we're also seeing that come down a little bit. And we forced some of that volume of forecasted through both in the Payette system. And this one has a little different flows. We watch we call it horsey. It's a horseshoe bend flow. We try to keep it below about 12,000 or so. So we watch that. And then this is, where's our Cascade and Deadwood is combined release. And then this is our demand that we're meeting. So this section area where we aren't meeting demand with our flow, it's being met by the natural flow. Here's Cascade. Cascade showing a little FRM possibly happening. Again, if our forecasts go down, these bumps could either flatline. We could go just straight up to about 1,500 and flatline them. So take these with a grain of salt. Same with Deadwood. Deadwood operation could see some FRM there. We have a little different opportunity at Deadwood this year. We're able to use the spillway. So in previous years, they didn't want us to use the spillway. So this year we can use the spillway if needed. So it will make it a little bit easier to fill that system. And Owyhee. So Owyhee is still looking pretty low at 128 calves contents, 40% of average. But as Aaron said, it's looking pretty good over there. We're seeing 593 calf at 112% of average, which would greatly help that system. And then we ran a bunch of years through here, and looking at our median, we could get up near 550,000 acre feet of storage, which is very good for them to be able to get that after such a bad carryover year. And ultimately, this is our February 1 forecast. We'll be meeting with the Corps to go over and do some most likely some mid-month forecasts, and we'll have some different numbers in there. But that's where we're at for now.
Very good, Ryan. Any questions for Ryan?
Just curious if he's expecting Boise system to fill, if they're forecasting, what, 1,500?
Yes, it would. Yeah, from some of the stuff I ran, it looked like if we had, I was seeing about 1 million. It was getting 1 million acre feet forecasted to look pretty good. But I'd have to look. I'd have to run through that again. But that's what I was seeing, just running through it real quick.
So the probability is pretty high that we'll fill the Boise system.
Well, I'd never tell you. So, I mean, I can't really say that. I mean, yes, the probability is higher.
Yeah.
But I never want
It
to say
all
much.
depends on what happens in the spring.
Yeah, I ran 2021 through our model, and it was really bad. So
yeah, no, it doesn't fill under those conditions.
No.
Okay, I'm not sure who's presenting with the Army Corps. Go ahead.
All right. Hey, everybody. My name is Grant Bell, Reservoir Regulator for the Corps of Engineers out of the Walla Walla District. I'm going to go through a fairly quick Snake River update. Starting with the Boise system, I think Ryan did a great job of explaining where we're at and what our outlook is. Our January 1st forecast was 1,750 CAF, 112% of 30-year average. Our February 1st forecast, like Ryan said, came in at 1,550 CAF, or 104% of average. So it's starting to trend more towards average. As far as operations are concerned, our model runs seem to coincide with the Bureau's. Our beginning of month model run showed a pretty good chance of a mid-March FRM releases. But as the month has progressed, that date's been pushing farther and farther back. So I'd say there's still a chance of a later March FRM release, but as time goes on, I wouldn't be surprised if that gets pushed a little farther back towards maybe beginning of April. Currently, we have 421 CAF of space through the system out of a required 300 CAF, so we are running below our FRM targets. Internal system regulation is still in the hands of Bureau of Reclamation. Moving on to the Clearwater Basin, January 5th forecast was 2,178 CAF, 88%. February 3rd forecast is 2,117 CAF, 86% of average. As a reminder, we're now operating Dorshack using the ESP forecast traces. So as far as Dorshack operations are concerned, our system is still below rule curve. Looking at model results, it looks like towards the end of March, we'll start to get close to our FRM targets. The Corps is currently discussing the possibility of some end of April releases. I don't think there's much more to say on that at this point. I don't know if it's particularly likely, but it's something being analyzed and discussed. And so in the meantime, Dorshack is maintaining minimum discharge of 1,700 cubic feet per second. Then moving on to Lower Snake briefly, the extended forecast is still showing below average flow conditions. Only other operational thing of note is the Clearwater Snake confluence. There's still ongoing dredging going on. That's all I have for today. Are there any questions?
Any questions for Grant? Well, we'll go on to Mark Robertson with who has a Boise snowpack model he'll show us, and then we'll go on to Idaho Power after that.
Oh, you're good. It's more me.
Give us a minute to set things up, and then we'll have Mark go. No pressure, Kara.
Yeah, and it's the laptop mouse guy. Yeah.
And the mic. Oh man, I'm rolling in with a bang here. Thanks everybody. Thanks for having me. My name is Mark Robertson. I'm with M3 Works. We run a physically based snowpack model. Much of our work is in collaboration with the airborne snow observatories, and we model operationally in real time across most of the Sierras in California and then a good chunk of Colorado. We presented here in the annual meeting in November, I think. It was a retrospective run on just the Boise Basin. So I'll show more of the Boise Basin results today. We're actually running it in real time. It's in the backyard here, so it's kind of fun just to show what's available. I will streamline this as much as possible, recognizing we're kind of late. But also, I'm going to be honest and just say the only reason I come to these is to listen to Troy and the Weather Service. Every time, I just hope that I come in here and he'll dial it up and say, I know what it's going to be. We figured it out. So I don't know. That wasn't this time, but maybe next time, Troy. So yeah, here we go. The blue line here, this is what we're all familiar with from the SNOTEL folks. This is the SNOTEL Site Index Median SWE for the Boise Basin. The black line is our modeled mean SWE for the Boise Basin. These are really apples and oranges here. So they're two different things. It's a site index in the blue line, SNOTEL, versus an actual full basin model in the black line. And I'm sorry, the dashed orange line is the SNOTEL median there, 30-year median. So these are really not the same thing we're comparing to, but the magnitude difference means nothing. But it's, as we do more retrospective runs, that difference between them will become more meaningful. So the thin blue line is water year 22, what happened last year, sort of that horrific dry period. And something that really stuck out to me, the thin black line is what the model showed last year. And it showed melt starting much earlier than the SNOTEL site index. And it's interesting to us. I think there's a lot of information available in the model that we can sort of pull out operationally, even outside of an actual streamflow model, but just to inform snowpack conditions in general. So we'll see how this year goes. This is results through 2 days ago, so it didn't quite pick up this recent storm, but at least we have some reason to think it won't be a repeat of last year. I won't hit this I won't go too slow here. This is a station comparison, so how the model is doing compared to SNOTEL sites. It's difficult to compare a 50 square meter model pixel to, say 2 square meter SNOTEL or pillow, but it's all we've got. That's what we like to do. In model land here, this is excellent results. I think this is right where we want to be for the most part. You can see prairie, we're diverging a little bit. The energy balance is a little off there. If this was an operational model run, we would take a closer look at the energetics of prairie and address that. But we are where we like to be here. We're a little high. The model's a little high at Galena Summit, Vienna Mine, and Dollarhide. So maybe we're a little high on total volume overall. That's certainly possible. But overall, pretty good. And last year, that followed the same trend. We captured the timing of melt, the onset of melt, with respect to the pillows. So I think in model land, we're doing a decent job. I'm capturing those energetics. Won't linger here. Model SWE distribution. This is volume on the left here. So that sideways histogram orange is showing the volume by elevation band. And then on the right, we've got the depth of SWE in the model is that blue interquartile range. And then on top of it, it's a little hard to see. I apologize for that. But we've got the SNOTEL sites as black diamonds. And then the model, the model pixel and the 8 nearest neighbors in orange there with error bars. So this is interesting to see at least how the model sees the storage in the basin. and how the sites themselves fall in that space. And some things jump out. Morris Creek Summit, of course, jumps out as having quite a bit more snow than most of the basin at that elevation. And we sort of know that from being up there and the experience there. And then Galena Summit, you know, Dollarhide show a little bit less than the basin on the whole at those elevations. So here's the change in volume for the month of January. Just obviously we had a lot of increase there. And then this is the change in SWE volume just for the last 12 days. You can see a little bit of melt happening all the way up almost to 9,000 feet. And that's pretty interesting. Not a lot of melts happening down low. What's going on here is solar radiation from, you know, a little bit warmer days and clear skies driving melt up at a little bit of melt up at the higher elevations. You don't see that down low because that melt has already happened. You know, the lower snow has been warm already and has already come off, but we're starting to see just a little bit at higher elevations, so that's kind of fun. Won't linger here. This is a comparison of this year's cold content to last year. Main takeaway is the snowpack, at least in model land, is just a little bit colder than it was last year. Another figure along the same vein. This is sort of a crude way to look at it, but it is basin-wide mean snow temperature. The blue line is this year up through 2 days ago. Orange line is last year, and at least in the model space, we are right now 1 to 1.5 degrees Celsius cooler snowpack than we were last year. So another indication that we're not quite as far along ripeness-wise. Snow density, I also won't linger here. Little more dense up in the Morris Creek area, a little less dense like in the Camas Prairie. And then snow density, skip right through this. The upper plot is this water year, the lower plot is last water year. So it's kind of two different x-axes there, but I'll just slap an arrow there showing where this year would fall on last year's plot. So we are also slightly less dense overall than last year, and that's sort of a proxy for snowpack ripeness or how far along it is in the melt process. So that's what we've got. Hopefully that's interesting. We're doing this sort of as a side project, but certainly if anybody has questions or is interested in this kind of information or would like to see other basins run, all that sort of thing, get in touch and let me know. And any questions, I'm here.
Any questions for Mark?
Yeah, this is Mark Zerski again. Curious, a couple years ago, we were hearing about some incorrect numbers or incorrect data, I guess, coming back from some of the snowtail sites that were due to people riding snowmobiles and things like that across pillows. And has that type of thing been corrected? And do we really not have that to worry about now?
Well, I'm not. This is really more Aaron Wharton's avenue here, but I was actually with the Idaho Snow Survey for a couple years. So hopefully I'm not jumping too far in front of myself here, but we did do our best to correct that data. Actually, I went up to Trinity 2 years ago to try to ground truth that and take a guess at it, but the snowmobiles tracked up so much area that we couldn't even ground truth. We just ground truth more snowmobile tracks. So I know they make every effort to do so. I think as far as I know, any non-corrected data, there's just no way to actually go back and correct it. So, but Aaron or anybody else, Danny Tappa, could jump on and correct me if I'm wrong there.
So Aaron, how are we doing as far as the snowtail sites go in the Boise? Are we still getting interference at the measurement sites?
That's honestly a Danny question if he's still on. Danny, are you there?
Yeah, I am here. Good question, Mark. I think, you know, we actually haven't really seen that impact this year, which is great. Seems like the snowmobile vandalizer person has moved on to new areas. But, you know, the overall impact on that really, it certainly, I think, actually, if anything, it increases the SWE total at the site because it causes a depression where the snow pillow is. So future snow that comes in will preferentially fill that void, but it has a much greater impact on the snow depth values that are output, and that isn't used in any of the forecast models or anything like Mark's talking about here. It has a lesser impact on the snow water equivalent at the stations, and like you mentioned, it wasn't multiple stations that we were aware of. It was Trinity Mountain Snowtel exclusively, where we saw this happening for a number of years in a row. But it appears the person is no longer doing it, thankfully. But in the grand scheme of things too, overall, like the absolute value of SWE from that site, I can't imagine it's introducing more than 1% or 2% maybe overall uncertainty or error. So pretty minimal overall. I will point out, while I'm talking here, Mark showed a comparison with Prairie Snowtel site. We have been having some issues, not from people messing with the snow pillow or the snow data, just the output from that station. So we've been looking into that for the last 4 or 5 weeks. I don't think those decreases like the blue line shows are real. So we're just getting some odd output, odd data from the snow pillow at that station, and we'll look into it more in the next couple weeks here.
Thanks, Danny. That's really helpful.
Yeah, thanks, Danny.
Any other questions? Going once, twice, gone. Okay. So now we're gonna, based on our last water supply meeting, there were some questions that came up regarding the cloud seeding program. So Kayla Golden with IDWR representing the board, and then Derek with Idaho Power Company are going to give us a little cloud seeding 101 just to bring everybody up to speed on the program. And this is a good opportunity to ask some more in-depth questions. So with that, we'll pass it over to Kayla.
Awesome. Thank you, David. I'll get my presentation pulled up. Maybe. Looks like my computer decided to freeze on me. Sorry. All right, awesome. There we go. Yeah, thank you, everyone. Again, my name is Kayla Golden. I'm with the Idaho Department of Water Resources. Specifically, I work in the Planning and Water Projects section, whose objective and mission is carrying out the work of the Idaho Water Resource Board. So in that position, I do oversee the state's cloud seeding program on behalf of the board, and we do work pretty closely with Idaho Power on some of our programs as well. So I'm going to start with a very brief overview of cloud seeding in Idaho, and then I'm going to turn things over to Derek Blestrud, Idaho Power's senior atmospheric scientist, to give us some 101, what is cloud seeding and the science behind it, and then he'll shore up with a February update on that also. So we thought it might be relevant really quickly to, I guess, give everyone a refresher on the difference between the department and the board. And really, they are two separate entities. So the department really serves as more of the regulatory body in Idaho, overseeing water rights, permitting, and then versus the Idaho Water Resource Board, whose objective is formulation and implementation of the state water plan, implementation and financing of large water projects, and the operation of programs that support sustainable management of Idaho's water resources. So that includes water supply bank, managed aquifer recharge, water transactions, financial programs that support water projects, as well as cloud seeding, which we'll be talking about today. So this, really quickly, I'm not going to get into detail on this. This just gives you a snapshot of how long cloud seeding has been occurring in Idaho. So starting in 1950 on the left-hand side, where you're seeing letters filled in with these columns are years when there has been cloud seeding operations in these regions of the state. So the left hand is broken out by a northern, southwestern, southern, and southeastern. So you can see there's been sporadic operations going on all over the state for a number of years. And then on the right-hand side, we've broken it out more by the basins that are currently operational today. So the Payette, the Boise Wood, the northern Upper Snake, and the southern Upper Snake. And so what you'll see is really since the early 2000s is when we had some consistent operations in our cloud seeding programs across the state. So currently we have operations in the Payette River Basin operated independently by Idaho Power. And then we operate in the Boise, the Wood, and both the northern and southern Upper Snake basins also operated by Idaho Power in partnership with the board and local water users. We do have about 4 separate programs currently that operate in the state of Idaho. The Idaho Collaborative Cloud Seeding Program, the one I just mentioned, that operates in the Boise, the Wood, and the Upper Snake. That is a collaboration between Idaho Power Company, who operates the program for us, and then the Idaho Water Resource Board and local water users in the basins of operation who provide funding support as well. And so these programs, and Derek will discuss what these differences are, but operate both remote ground programs and aircraft programs. Idaho Power then has their own independent project in the Payette River Basin that I mentioned. That project is separate from the collaborative, but it is operated in coordination with the other basins in the collaborative program, sort of as one region that we call the West Central Mountains. And then we have some other programs that operate in the eastern and southern portion of the state. So the High Country Resource Conservation and Development, that was a program that started in the 1980s and is operated by Let It Snow. They currently still operate in the Upper Snake with the manual program. So the state and Idaho Power do not participate in that program, though Idaho Power does provide forecasting support to them. And then as well, the state of Utah operates a few ground generators and equipment in the southern portion of the state that target their basins as well. So very quick snapshot, this lower basin or lower portion of Idaho here on the left, this is again what we call the West Central Mountain region where we have operational projects. The Payette being the upper left here, the Boise in the middle, and the Wood. You'll notice these X's or crosses, the orange and pink, represent our network of ground generators. There's lots of weather instrumentation in here as well. On the right-hand side is our Upper Snake project. And the green dots in here just go as a visual to show where the High Country RC&D manual program sort of overlaps with us as well. And it's not located on the map here, but the state of Utah operates down here in Box Elder and Cache counties in the southern portion of the state as well. So quick snapshot, excuse me, of how our programs have developed. The collaborative program, as I mentioned, really that got kicked off in the 1990s as a result of some stakeholder questions in Idaho Power. They began their first operational program in the Payette River Basin in 2003. Then in 2008, the power company proposed cloud seeding as a mechanism to support the Eastern Snake River Plain Comprehensive Aquifer Management Plan, otherwise known as the ESPA CAMP. So that occurred in 2008. And at that time, what was proposed was a 5-year pilot project to basically see if cloud seeding would be successful in the Upper Snake. So in the meantime, water users in the Wood and the Boise River Basin approached Idaho Power about beginning new projects, and they did get those implemented in 2013, 2014 timeframe. And then following the Upper Snake Basin pilot project, roughly around 2014, was when Idaho Power Company approached the state about developing a partnership, a longer-term partnership for the operation of cloud seeding in the basins of operation. So that including the Upper Snake, the Boise, and the Wood. And so that's really about when the collaborative program kicked off. In 2019, we reached our current program built out, which includes 3 aircraft and 57 remote ground generators and a network of weather instrumentation. So we've had some, I guess, a lot of changes with regard to cloud seeding in our state in the last couple of years. Just recently in 2021, the state of Idaho passed some legislation, noted Idaho House Bill 266, I've highlighted sort of the summary of this bill, and what it did was direct the Idaho Water Resource Board to, one, conduct an analysis of its existing projects to determine how cloud seeding impacts the hydrology of our basins. It also directed the board to complete an assessment of opportunities for cloud seeding in other basins or other areas of the state. And it as well provided the Idaho Water Resource Board the authority to authorize cloud seeding programs in Idaho. So essentially designated them as sort of a regulatory body of cloud seeding in Idaho, if you will. This legislation also provided the board authority to sponsor or develop local or statewide projects. And so this really is a high-level snapshot of how things have evolved since 2008. So here on the far left, and really since the state has started participating, if you will, we have the ESP camp beginning in 2008, showing our Upper Snake, Wood River, and Boise Basin projects coming online. I've put a star here to sort of denote where the state started participating in these programs. And some of the events that have happened since then, including House Bill 266 in 2021. And so really, a lot, as I said, a lot has gone on with this project in the last several years. Currently, the state participates in a number of different ways in cloud seeding. That's through cost sharing for the operations and maintenance and model development for our collaborative programs. The board has also undertaken several projects in the last couple of years, one of them being a cloud seeding impacts analysis to look at, again, how cloud seeding impacts our basins. A statewide assessment. This project was kicked off in late 2021, and the goal of this project is to give the state a high-level look at the opportunities for cloud seeding in other areas of the state. And then the board has as well kicked off some initial feasibility and design studies looking at potential opportunities to seed other areas of the state. But at this time, our board has not made any commitment to developing out other projects, currently just looking at what the opportunities are. And so lastly, before I turn things over to Derek, I thought it would be relevant to also give you some context of where cloud seeding occurs in the United States. There's both green and blue highlights here, the blue being wintertime cloud seeding of projects. These typically target the augmentation of snowpack, and then the ones in the green are warm season cloud seeding projects, and these are typically for rain enhancement or hail mitigation. But I guess in the United States overall, cloud seeding is certainly something that both Idaho and other states are implementing as a water management tool. So with that, I'm going to turn things over to Derek Blestrud with Idaho Power, and he's going to sort of give you a high-level cloud seeding 101. What is it, the science behind it, and maybe try and wrap up with some of the frequently asked questions.
Okay, so we'll hold off on questions with Kayla until the end. Go ahead.
All right. I'll jump right into what is normally our operations update and then finish off the cloud seeding thing since it has some of the same things in it. Our hydrology group usually presents what the forecast is for Brownlee, and they're not here, so they gave it to a meteorologist to try to explain what's going on. So they only gave me 2 slides to mess up on, so hopefully that doesn't happen. There's not too much going on. The current forecast for Brownlee right now is about 4.2 million acre feet of water, which is about 82% of normal. If you guys were here last month, that has dropped about 700,000 acre feet. So it has dropped substantially from last week or last month, and that just goes to as a result of the dry month that we've had. Here you can look at the operations of Hell's Canyon, where we're at currently in elevation. We'll drop a little bit until about the 1st of March before we start refilling. Looks to bottom out around 22,000, maybe 35, and we expect to fill later in June. So that's what's there. Next slide, or the next graph here has where the current Brownlee inflow versus Hell's Canyon outflow is. You can see when we had flat flows through the beginning or the end of last year, we're starting to do some following. Pretty low inflows, around 10,000 CFS of inflows. We'll start to ramp that up as we come through the runoff season. We're not looking at super high flows, but we're looking around 20,000 CFS that's there. So not a lot. Now let's jump back into the cloud seeding thing. Kayla talked a little bit about the Central Mountain project as well as the Upper Snake project and what's there. So I'll be brief on this. We have our two forms of seeding that we do in for the collaborative project, and that's with our ground-based generators. Here's a picture of one of those, as well as aircraft seeding. That's one of those. She also mentioned the High Country RCND and Let It Snow operates a manual generator cloud seeding project, and that includes these ground-based, they're manual generators. Someone has to go out there, first of all, drink the beer, and then start them up. No, they get out there and they fire these up. It's an old beer keg that has a solution in it, and they have the same type of setup that we do, only it takes a person to start them and to operate them. So as expected, over the course of the last month, we did not have the operations, a large amount of operations, and this goes to the drier, the normal January that we had. Here in the Central Mountains, normally we run our generators around 550 hours. They only got about 450 hours of actual runtime. Aircraft, on the other hand, was less than half of what you expect. We expect around 46 hours. We only had about 21. And even the chemical that we released, so the burn in place as well as the ejectable flares, there's a substantial drop off in those numbers as well. Jumping down to the Upper Snake, it's kind of the same story. We're well below average in generator hours, well below average in aircraft flight hours, and actual usage is not as low, but it's still lower than what we expect to date. So operations wise, we were pretty low for the month of January. Hopefully, in the first part of February, we followed that trend. Hopefully we have a change next week as we get more systems moving through. I'll move on to the next presentation that I have. That is a continuation of what Kayla was talking about, and it's just an overview of what is cloud seeding, a little bit, a brief cloud seeding 101. If any of you guys have heard us give this presentation before, it's usually, a half hour to 45 minutes. So this is going to be really brief. So I'm going to try to go quick. What cloud seeding does, especially in the cold weather or cold clouds that we have for wintertime cloud seeding, is it's reliant on what I call the coolest terminology in meteorology. It's supercool liquid water. So it's water that's in the atmosphere, and it can be cooled below the freezing point of 32. The freezing point isn't actually a freezing point. It just, when stuff happens, it's more like a melting point. Water always melts at 32 degrees Fahrenheit, but it doesn't necessarily freeze at 32 degrees Fahrenheit. In a laboratory setting, you can have supercool liquid water as low as minus 40 degrees. So really cold. In nature, we've probably seen it, at least in Idaho, we've seen it around minus 25 to minus 30 on our cloud seeding projects that were here. So substantially colder than what it is. And what this water does, or when it's super cool, it needs something to teach it how to freeze. And here you can see some of our weather equipment. And this had super cool liquid water that was being transported by wind. And then once it comes in contact with the weather equipment, it instantaneously freezes and starts the growth of an ice crystal. So once you bring that ice crystal into the atmosphere, the same thing's going on, and this is what produces snowflakes. So in the atmosphere, you have supercool liquid water, and then something has to come along to teach it how to freeze. And so that could be a dust particle, it can be an aerosol particle, it can be something else. But once it comes in contact with that supercool liquid water, it instantaneously freezes it. It forms that hexagonal shape of an ice crystal, and then more water vapor or supercool liquid droplets get put on it, and that continues to grow that snowflake to a size that eventually can fall to the ground as precipitation or snowfall. In this case, this is representing a dendrite snowflake, and so a lot of times once that snowflake starts, if you have this additional branch that's on there that breaks out, it can form another ice crystal, and then it pops back up to this and it starts growing the next snowflake. So that's called ice multiplication. So how cloud seeding works is in nature, you have this natural system that comes in and interacts with the mountain range, and that's causing lift in the atmosphere. Lift causes cooling, which causes evaporation and causes that water to become super cooled. And once that water particle gets cold enough and interacts with one of those ice nuclei or the dust particles, it forms a snowflake, and then it continues to grow, and eventually it falls out to the ground as snowflakes. What cloud seeding does is it introduces a whole bunch of these into the atmosphere. And so you get more of them, and they also are more efficient at transitioning that supercool liquid water to an ice particle. Those dust particles aren't very effective. It usually takes about the temperature has to be about 5 degrees Fahrenheit before they become effective and start growing snowflakes. The chemical that we use is silver iodide, or it's hexagonal in shape. So it mimics that ice crystal, and that actually starts at about 23 degrees Fahrenheit, so much warmer, so earlier on in the cloud as it's rising up. And so you have a longer distance or a longer time period for that snowflake to actually get to a size that can fall out and fall as snowfall. Here's a look at us doing some cloud seeding back on the Snowy project in 2017, and it has a radar image of one of our missions. Here you can see the background image. There's not much happening. Where you see some of these blues and purples, this is a little natural precipitation event that's going on. We had an aircraft that came from Boise and it's following this yellow line. It came up to the northwest part of the track, down to the southeast, and then came back here, and it was seeding the whole time. And as the aircraft released the silver iodide particles in the atmosphere, they started to form some precipitation. You can see that aircraft is moving a little bit, and I got lots of meetings apparently popping up. And there's not much happening originally right after it, but you'll start to notice a few time frames later, you start to see some individual precipitation forming downwind of where that aircraft flew and started seeding. And these lines became more and more developed as the storm system moved along. So this is the first part of that seeding event, and you start to see that zigzag pattern, and you really start to see that precipitation forming from the seeding that was going on. One of the cool things is with our aircraft that we have is we seed by two mechanisms. One is a burn-in-place flare. That's a flare that stays on the wing, and as the aircraft flies back and forth, it releases a continuous trail of silver iodide. And you see that in these images. You see that continuous trail of seeding that's occurring. But we also have ejectable flares, and these are dropped from the aircraft about every 30 seconds. And on a few of these legs, we only use the ejectable flares, and you start to see each one of those individual flares as it's falling through the cloud, and you start to see that each individual little area that started popping up with the precipitation that was from those ejectable flares. We quit seeding, and the precipitation eventually moved out of the target area. But I'll run this loop a little bit, and you can see that aircraft moving back and forth, and you really start to see the benefits from cloud seeding as it's going downwind. So this is, in a nutshell, this is an idealized case. It's very hard to find a case without any natural precipitation. Then you see the actual increase in snowfall from beyond it. But this is what we're trying to do with cloud seeding. The same thing can be done from the ground with the ground-based generators. It's just really hard to have a radar right next to the ground that you can see that same thing happening. Hopefully in the future we'll have some research that shows that as well. So some of the benefit estimates. So this is all good. So what is the benefit that we see from cloud seeding? And the one thing that we have been doing since the start of our project back in 2003 is looking at a target control analysis. And so this is looking at a relationship of snowtail gauges that are inside the target area or inside the Payette River Basin. This is the first project the area that we started cloud seeding, so it's the longest area that we have a data set for. And since 2003, we started cloud seeding, and so we looked at snowtail data before that. Each one of these non-colored dots is a representation of a cloud seeding event that happened. I see it's cutting off the bottom on this presentation, but the target area sites are on the y-axis, and on the x-axis is the control site. So those are SNOTEL gauges outside the target area that aren't being affected by cloud seeding, but in a similar area, so they have a similar weather pattern to what's happening. And so you get a relationship of what's going on outside the target area versus inside the target area on each year, and you plot those to each other. And then you can fit a regression equation to that, or a one-to-one line that we have. And then you looked at years after cloud seeding happened, and if there's a shift in that, then you can attribute that to cloud seeding. And that's what's happened. All these colored dots are years after cloud seeding happened, and you see it's a shift up in those values. So if you plot a one-to-one line on those, it would be up here or something, and it's about 11% increase over what we had over the time before cloud seeding happened. And so here's a look at more of the areas that we've looked at to run that same target control analysis areas of, and you can see that that was the pay-up basin that I just showed you. Last year was about a 6.6% increase. The overall average is 11.2 since 2003. We got a couple basins in the Boise. We've split the Boise into a couple different regions, and you see about 11% increase there as well. The Wood River showing a 9 to a 10% increase. You get out east in the Henry's Fork. This is an area that's a lot harder to target for cloud seeding, and you see a benefit that's somewhere in the 4 to 5 to 6% range. And then the Upper Snake, so the rest of the Upper Snake has anywhere between a 7 and a 10% increase in precipitation. So what we've done is we've taken these percent increases of these basins, and then we've thrown them into our operations hydrology group, has put them into a river forecasting model to try to calculate what is the benefit in acre feet of water that's there. And so they've took roughly a 50-year period where they've ran what's occurred naturally, and then they put a 10% increase. This was before cloud seeding happened. And then they ran that 50-year period, plus they did it again with a 10% increase or whatever those percent increases from the target control analysis. And that gives you an average benefit that occurs from that percent increase in water. And in the Payette River Basin, on average, we get about 225,000 acre feet of water additional from cloud seeding. The Boise is pretty close to that. The Woods, 110,000 acre feet of water. The Upper Snake has, a lot more, but across southern Idaho and the cloud seeding basins, we're looking at over 1 million acre feet of additional water that's available from cloud seeding. And if you take that amount of acre feet and divide it by how much the amount that we spend, cost of the project divided by the amount of acre feet of water, it comes out to about $2.80 for each additional acre foot of water that's created from cloud seeding. So it's pretty beneficial. Real quickly, some of the questions that always pop up. So if you're taking this water out of, or you're depositing in Idaho, what's that doing for Wyoming? What's that doing for Montana? Is it causing a decrease in precipitation downwind? This is, downwind effects or extra area effects. And all the research out there shows that it's either a neutral or a positive effect downwind. None of them actually show a decrease in precipitation. And that kind of goes against what you think of, but the atmosphere is very complex. And so what's going on, here's just, another slide I had, some of the research that's out there that shows the positive effects downwind. But when you take, for a 15% increase in precipitation, you're taking actually very little bit of water out of the atmosphere. So in the total atmospheric water budget that's there, nature's only about 20% effective in transitioning the water vapor in the atmosphere into a cloud. And then that cloud is only about 30% efficient in transferring that water vapor that's in the cloud or water droplets in the cloud into precipitation on the ground. And so you're looking at only about 6% of the total available water that's in the atmosphere that actually reaches the ground as precipitation. And if you would have a 15% increase in the amount of precipitation on the ground that we do, that's taking less than 0.9 or less than 1% of the full water budget out of the atmosphere. So it's taking very little of little bit of water out of the atmosphere. Plus the storms that move across the basins are very dynamic. We talk about atmospheric rivers all the time. This acts as almost like a hose that's into a cloud or into a storm system. That storm system moves across a basin, and then you have this flow of water that comes into the storm and out the other side. And that's continually moving through that storm as it's transitioning across the region. If mountain ranges or even the Rocky Mountains as a whole would wring out all the water in the atmosphere, there would not be anything left in the plain states. So like North Dakota through Texas would have zero precipitation. But what happens is that storm continues to move on, and that atmospheric river actually gets dissipated, but it picks up another tap of moisture that comes from the Gulf of Mexico. And so that storm's still intact, but it has a different hose that comes into it. And so the atmosphere is just so dynamic that it actually replenishes the water that's lost from cloud seeding really rapidly. And so that's why you don't see any downwind effects. The other question that we have is we're using silver iodide, so is it harmful to the environment? The short answer is no. Silver iodide is inert, so it's not available for aquatic organisms to ingest. The WMA has put out a statement. The WMA is Weather Modification Association. They've looked at all the research out there, all the toxicity reports, and none of them show an environmentally harmful effect. Australia has a project in the snowy hydro, and their regulative agency has looked into their project, and they show that there's no evidence that the trial has had any adverse environmental impacts on the project. There's, Idaho Department of IDEQ actually did a review of our project, and they said that it was unlikely that cloud seeding will cause a detectable increase in silver concentrations in the target area. We're just using so little, there's just hardly any bit of chemical that's used that it just doesn't cause any increases or detectable increases in the areas. There's a whole bunch of different environmental studies that have been out there, and here's a list of several of them. They're showing no evidence of any adverse effects to human health or the environment. The other thing that comes up as well, if you're increasing precipitation, is there a risk of flooding? And we have very strict seeding suspension criteria. So if you have an excess snowpack, we don't seed. If there's a chance of rain on snow, there's no seeding that's done. That's why we have meteorologists on the project that continually look at this and make sure that we're only seeding storms that are good for snow increases that we have. Little bit of our suspension criteria. I'll just skip over this since there's not a lot. You can see how in different cases, this was back in 2017, big snowpack. This is the median values of a snowtail gauge or a combination of snowtail gauges in Boise South, and our suspension criteria. Once that crosses or even gets close to it, we suspend operations. Here's just a National Weather Service radar from Pocatello, and you can see kind of the same type of zigzag lines that's forming over here from seeding aircraft in the Upper Snake. So just has a secondary look at it from some of the Boise, or from a National Weather Service radar. So that was really quick and really fast. Any questions?
That was a very nice presentation. Any questions for Derek or Kayla?
Yeah, this is Brian from Reclamation. On the council, like the other areas that are cloud seeding in the West, what kind of benefits are they seeing as far as like acre feet per input, say by silver or precipitable material? And is that comparable to what you all are seeing at Idaho Power?
So I can relate to what the studies have been out there and what other project has done. Utah has did some of their studies, and they're all showing between a 5 and 15% increase in the basins that's there. So that's right on par with what we show. One thing that within Idaho Power and now IDWR, when we're running our projects, we definitely look at the science side of things. A lot of the projects elsewhere don't necessarily keep that up. They just operate under the assumption that they're increasing more precipitation. So we actually don't know, and we don't hear about their increases, but the studies out there show that they're on par with what we have.
Okay, cool. Thanks, Derek.
So there was a chart that you had about this year you had you had less cloud seeding operations going on compared to previous years. And is that just because of ideal conditions that there haven't been as many ideal conditions this year compared to previous years?
Yeah, that chart was a little misleading. It was just January. If I would have had November and December, you'd see there was a substantial amount of cloud seeding that occurred during those months. In January, we had less than normal because there just wasn't the opportunity to seed.
So very good. We've kind of run longer than usual, so we'll wrap things up here. Feel free to ask questions to anybody in the room. And we have recorded this, and we'll try to get it posted this evening. We'll see if that happens. Okay. Thank you. Bye.